Imagine you're living in your dream home. You come home one day and there's a new lock on the door, and the person with the key is asking you to pay before you have access to your own home. Now that sounds crazy, but it does happen. In the cyber world, we call this ransomware. Stay tuned, watch this short clip, and when we come back, we're going to build our own ransomware to simulate how this attack works so you can have a better understanding of it. I'll be right back. What is ransomware? Ransomware is a type of malware that infects computers, encrypts files, and demands payments for their release. It's as if someone has taken your digital possessions hostage and won't return them unless you pay up. There are primarily three types of ransomware. Encrypting ransomware. This is the most common type, which encrypts your files and demands a ransom for the decryption key. Locker ransomware. Unlike encrypting ransomware, this type of ransomware locks you out of your entire device, not just specific files, demanding a ransom to regain access. Scareware. This pretends to be legitimate software like an antivirus that claims to have found issues on your device and demands payments to fix them. It's often less harmful, but can be just as annoying. So how does ransomware operate? The typical ransomware attack starts with a phishing email or a security vulnerability in your system. For example, you get tricked into clicking a suspicious link in your email or download a file that contains the malware. Once the malware enters your system, depending on its type, it either encrypts your files, locks your device, or scares you into paying for unnecessary services. The impact of ransomware can be devastating. For individuals, it means loss of personal documents and memories. For businesses, it disrupts operations and can lead to significant financial losses and reputational damage. To prevent ransomware, both individuals and enterprises need to be proactive. Regularly back up your data, keep your systems updated, and be cautious of suspicious links and emails. For businesses, additional measures like cybersecurity training, network segmentation, and advanced threat detection are crucial. What to do if you're a victim of ransomware? If ransomware strikes, immediate action is crucial. Start by isolating the affected systems to prevent the spread of malware. For enterprises, activate your incident response plan. Notify stakeholders and engage a cybersecurity firm if needed. Avoid paying the ransom as it doesn't guarantee data recovery and encourages further criminal activity. Instead, report the incident to law enforcement to help track the attackers and understand any legal implications, especially if sensitive data is involved. Ransomware is evolving, employing more sophisticated techniques like double extortion. This involves not just encrypting data, but also threatening to release it publicly unless the ransom is paid. Staying updated with the latest security practices and technologies is key to defending against these threats. In conclusion, understanding ransomware and preparing for it is essential in our increasingly digital world. By staying vigilant and implementing robust security measures, we can protect our digital assets and ensure that our data doesn't vanish like a magician's trick. Join me for the next part of this video where we will build our own ransomware and simulate how this attack works. Stay tuned. And now we're at the exciting part. This is where we'll build our ransomware. We'll have a Windows 11 victim machine. We'll have a Kali Linux attacker machine, a Python-based ransomware simulator that we'll build, a simple phishing email to social engineer the user into clicking on our malicious link. That link will lead to our malware download site hosting the ransomware, running the malware on the victim's machine and encrypting all the files, and creating a ransom demand file on the victim's desktop, requesting decryption key, and decrypting the actual files that have been encrypted with the key that we receive back. Stay tuned. I'll be right back. Hello and welcome back. We are going to build a ransomware simulator. Emphasis on the simulator. This is meant to act like a real world scenario. Mind you, the script we're building is highly capable of encrypting files in the way a real world scenario would work. So just be mindful if you do end up trying this out in your lab environment. Just to kind of walk you high level overview of what we're doing. We're building a Python script that's capable of encryption. It's capable of encrypting any file or folder path that we pass to it. The keys are generated ad hoc during the encryption process. We send these keys to ourselves via email. We'll try to create some forensic cleanup by creating a self-destruct script that will basically remove the script that we're running. This part is primarily after we've converted the script into an exe. So in the end, what we will be doing is converting our Python script into an executable using PyInstaller. We'll talk about that as we go on. We'll set up a simple HTML site. We'll run a simple Python web server as well, so we can host that malicious exe that we end up generating. We'll send a phishing email to an attacker to mimic what happens in the real world, and then we'll demonstrate how these elements kind of play together. Just to give you an overview, these are the things that we're working on as far as the script is concerned. We have a resource path, which basically is responsible for pulling paths, URIs, and so forth. Get system information. This would be the method that we use to kind of grab system information from the device that we're encrypting. Create system info file. We'll use that to generate the information that we grab in this method. Read configuration file. What we'll be doing is employing an SMTP configuration file. So this will be responsible for reading those configuration data from that. Encrypt file, responsible for encrypting a single file. Generate AES key. This would be our method that generates that ad hoc 256-bit AES key. And send email. This is the big part of our script. This is basically going to be responsible for doing all the encryption as it ties all these other methods into it, such as encrypt system folder and get script and all that. And then securely delete. This is where we're using this method to delete any file that we want to clean up, any activity. This is basically our secure delete file, where we're running several passes of deletion to delete any file that we write into the system, just to clean up forensically as well too. Create notification file. This would be where we create our notification file and place it on the desktop of the device that we encrypted, telling them, hey, you need to contact blah 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 for your ransomware keys. We'll create a self-destruct script. This method will do that. This will basically create a script on Windows, which will run every time we run the script to try to delete this script itself. Is admin. We're just using this method to check for admin privileges in some of our methods or some of our activities that we're doing. So for example, we'll see if this person is an admin, we want to like encrypt the entire user folder, since they can do that. Mindful of this method, not very good. And then our encrypt system is basically where we do all the encryption of folders. We're recursively running down everything, so this should be responsible for that. Get script. This is where we basically try to get the relative path of whatever script we're running or exe file during runtime. And then encrypt directory is basically we use this to encrypt every single directory recursively. And this, let me hit this down a little bit. So this is our decryption script as well. Very simple. There'll be about 3 or 4 methods. We'll have a decrypt file responsible for decrypting a single file. We'll have a decrypt folder path, which basically also takes a relative path, home folder or whatever, and decrypts all the files in it recursively as well. And then write decryption summary. This is where we'll use this method to write output of everything that we've been doing as far as like the actions are concerned. I believe we have the same method, something similar for the encryption, where we'll create, I think it's going to be in create system information file. We'll do that in there as well too. Yep. So stay tuned. I'll be right back. I'm going to get this code all written up. When I come back, we'll walk through it again and then we'll start our simulation and see how things go. Stay tuned. I'll be right back. Okay, welcome back. So our code is pretty much done. I'm gonna walk through it just one more time just to recap so we can remember what we're doing. So as I mentioned, we are setting up some login here. The idea is to log every event that we carry out, whether it's a decryption or encryption. We'll find that same mechanism in the decryption script as well. Encrypted files here, I'm keeping pretty much a dictionary of all the files and folders that we encrypt. I will be using that to create a file as well that we send back to ourselves, just so we know what files and folders we encrypted. Resource path, as I mentioned, this gets the relative path of the script. If you notice this is in preparation for when we do convert this into an executable. So PyInstaller has this funny way of keeping track of internal folders to the application. It creates this memory space that it stores these documents. So this is what we're calling here basically. Get system info, as I mentioned, this is just grabbing computer name, current user, IP address, MAC address, and so forth. We are doing a create system info file. This is the method that actually uses this information to create a file. This file also gets sent to us. Read configuration file, this is where we read our SMTP credentials and so forth. And that reminds me, I need to create the I do need to create the config file. So let me do that real quick so I do not forget. So config that ini, and I believe we called it email credentials. I will double check that. Email credentials. Close that, and you would need a user, you need a password, you'll need a recipient. So the user would basically be the username or your email. Password would be the password that you create, and recipient will be same email or whatever email you want this to go to. Credentials, I need to correct that. And just be mindful, in the past, if you were using something like Gmail, this would be basically you allowing secure apps. Nowadays it's actually called, you basically create an app password if you're using Gmail. So just be mindful in case you're wondering how to create that. I do have this somewhere, so I'm actually just gonna grab it and put it in there so I don't have to type this out. So my configuration file should be good, and it's all good there. So I'm going back to our script. Let me go back to our script, and just continuing to walk through it. So encrypt file, as I mentioned, we are using this to encrypt a single file. This will just basically take the path of the file, and we're creating a new AES key. We're using AES mode EAX to generate the cipher and pretty much generate AES key. This is where we actually generate our key. Send email, as I mentioned, this would be like the big part of our script. Basically this goes through, creates the email, attaches each of the files. As you see here, we're attaching the log file, if I can see it, key file, sorry. And then here we're doing the system info file, and then we're attaching the log file, and then we'll just shoot that off as an email to ourselves. Securely delete, as you can see, we're running default 10 passes. The goal here is that, you typically delete a file forensic purposes, so we're running several passes of delete just to make sure, running over random bytes to make sure this is forensically not able to be retrievable. And then we go to create notification file. This is where we actually create our notification file. This is what we drop on the user's desktop. What we're doing here is checking if they're an admin. We're dropping it in, we're picking up user profile basically and dropping it on their desktop, essentially. And just to be careful, for some reason, if we can't write to certain directories, we're just gonna create like our own kind of temp directory and place them in there. And then down here we're doing create self-destruct script. This is where we're creating the scripts that will run after our exe has run. So when we test this out as the script, this will pretty much not be as useful until we've converted our script into an executable. The what we're doing here is pretty much we're creating a script on, if it's Windows, we're creating a script, and we're checking every 5 seconds to make sure that our current script is not running, which is going to be this file name. That's what we're going to name it as. And then once we're done with that, we basically delete it. So this will basically be timing out every 5 seconds just to see if this script is still running. It shouldn't be able to delete it anyway, because there should be like a lock on the file anyway, so that should be fine. But we're just making sure we're covering our backs to make sure it actually deletes it once it's done, so that's fine. Is admin, as I mentioned, this is where we do some admin checks. We're using ctypes just to make sure that we're actually grabbing admin. The goal behind this method actually is that eventually what we'll do is, in encrypt system, as you can see down here, if it's an admin, we realize that we do realize that we can now encrypt basically everything on the drive. So we're basically going to encrypt every user folder, as you can see. And if it's Linux, we're going to encrypt everything that's on the home directory. So yeah, just be mindful. I did do a little bit of some cleanup here because I don't want to delete. So eventually in this part of the script, we're actually doing the cleanup. So if you can see, I'm calling the securely delete on system info file. All the files that we generate while our script is running that we eventually send to ourselves, we don't want it on the device anyway, right? Because that's the key file and so forth. So we are deleting them here, but I've just commented these out for now because I do want to have them just for testing purposes, but we'll check it out. And then get script directory. This is also the same thing. We're actually doing this because of the executable that will run in PyInstaller to ensure that we have the exact script relative path or absolute path when we attempt to delete it. And then encrypt directory, this essentially just encrypts the directory recursively. So we grab everything, and however down or deep the levels go, we continue to encrypt stuff until we're done with it. So yep, that's it. Our encryption script is ready. I do think there's a couple of cleanups I need to do. So PyCrypto, this is complaining. I think it's complaining because I haven't set up this needs this actually needs PyCrypto DOM library. So let me do pip install PyCrypto DOM. That should take care of that. We should see that clear up once that's installed. Awesome, that's good. I'm gonna clear that terminal and I'll do a save again, and you notice that it's gone. So we got that fixed. So I think let me just, and then since we're walking through the script, let me just go ahead and walk through the decryption one as well too, since that's also there. So let me grab this here. Same thing here, login, simple, it's very basic. Creating a log file, decrypted files. We are going to create a file like with a list of the things that we decrypted, just to match it up with the things we encrypted. Decrypt file takes care of decrypting a single file. Decrypt folder, basically the same thing. Recursively, we're going down the levels of every folder and decrypting all the files that were in there. So, and then write decryption summary. This is where we basically spit out a file that says these are the files and folders that we decrypted and so forth. Over here, the three main things that you should notice or take note of are the arguments. So the decryption obviously takes some arguments. Basically, folder path will be whatever path to the folder that we're attempting to decrypt its content. So if this was your user folder or home directory, then that would be that path. And then the second one would be the key file. Assuming the ransomware creator sends you pay your ransom, they send you a key, that would be the key. And this one is an optional argument, basically, if for any reason you wanted to exclude some directories while you're encrypting. So that's good. So let's set things up. Let's go back to our encryption. I'll minimize this. I'm actually gonna open up a file explorer, and what I did here was also create a bunch of some test files and folders just to kind of mimic what we will be doing. So this fake entire documents folder is basically mimicking like this documents folder, what would naturally be your documents folder. Right now I'm just testing the script until we actually build it out in into an exe and we'll run it fully. So we just want to make sure it's working. So I'm going to test this out. We'll run through, make sure it's working, and then we'll take it from there. So this is one of the folders we actually will be encrypting. So fake entire folder documents folder. I put some random test data in there. Random folder file 1. This is just a text file. Oh, that's I think that was one of the old ones. So let me do this. Let's delete that. Delete, yes. And then I'll just create a copy of this and rename it. And that's taken forever. There you go. Okay, good. So I will just do this. Rename that. Rename that. So check it out and see what's in there. Yes, so this is good. This is an unencrypted file. We open this one up again. This is an unencrypted file. Says this is the test data one for our encryption. I added some images just to be sure. That opens up good, no issues. Open the second image. I even added a test Word document, and there you go. So all looks good. Okay, good. So this will be the folder we're gonna run test against. That's this folder. Okay, let me pin that so that way we can always get back to it. Where is it? Pin to quick access. There you go. Okay, good. So what I'm gonna do is I'm gonna snap this actually in here, and then I'm gonna go to email on this one, and then I'm gonna go to that on this one and this. So good. So now we have both our encryption script open, decryption. I have my email here just to be able to grab the encryption key. Just to walk you through what's gonna happen when I run this script, we should see an email pop up here, basically with three things: the key to the encryption, the encryption key, a system information file that basically will tell us all the folders and files that it encrypted, and the log file that basically tells us every action that was performed, whether there's errors and so forth and all that. And then we'll come back here and check this folder back to see if the contents are still encrypted or not. I'll open it one more time, just here. Open a random folder in there, open it up. This is good. Open this up. Image still works, good. So let me go ahead and actually run. I'll just make this a little big for now, like so we can see it, and I'll drag this up. And then what we're gonna do is we are going to and as you can see here actually, so this is what it will ideally be like. This program would run and basically expand user, which is essentially looking for the current user that's running this script. It will look for their home folder, but I've commented this out because I don't want to do that yet. I just want to test this. Since we're testing this for now, I want to test it on a specific folder, so hopefully that helps. So right, good. Let's go ahead and run this now. As I mentioned, we run this, we should see our email update with some files, and we should see these things turn to pretty much gibberish. So let's go ahead and run this. Let's go. So run, it's running. You can see here, boom, our email updated. There you go. We see an encryption key, system info, and operation log. We open that up. There should be three files as I mentioned. There's the key file, there's a system info file. Just to verify, I'm gonna open the system info file for now. And look at that, it tells us computer name is Windows 10, operating system is Windows 10, computer name is Windows 11 Lab. We are gonna verify this just briefly, so let's do this real quick. What I'll do is I'll just open up a command prompt, and then I'll just do ipconfig just to see what the IP, and that is that's 52.131. That's correct. MAC address should be same. This is correct, so I'm not even gonna bother. Operating system name we already know, we can see it here. It's Windows 11, where whatever it says Windows 10 blah blah blah, but it's Windows 11 Lab. So that's the computer name actually, and then current user is Griot, so we can see current user here, Griot. That's perfect. We see the encrypted files and folders. It tells us everything it did. And right now we can already verify, even without opening these files, we can see that it did go in and encrypt that fake entire folder that we had given it. But let's go ahead and confirm. Before I do that, let me open the log file just to see what it looks like. So the log file is telling us timestamps and what it was doing and so forth, all the way down there. You see that. So great. So the script is working. Now let's open a file just to make sure that everything was indeed encrypted. Random folder in that folder. Open file. Gibberish. It was encrypted. Image, we shouldn't be able to see it now because it's encrypted. There you go. PyCrypto, the Word document, look at all that. It's gibberish. So we know our script is working. Now, perfect. Let's go on and check out the decryption. Since we have the key here, we will do this. I'll just open another window, another Explorer window, and I'll do Control New. Let's go to Downloads. Make sure there's nothing in there. There's only PyCharm. I can delete that. So we'll leave this open here and I'll download the key file. Perfect. So now we have the key. We just downloaded the key file. So I know it's in downloads. What I'll do is go back to decryption. I'm going to make that a little bigger. And what I'm going to try to do here, since this takes arguments, I'm actually just going to run this in the terminal. So I'll open up the terminal. I'll take it all the way up. And we can see that we run this by passing it 2 arguments. The third one is optional, so we don't need to worry about that. So what I'll do is just run it decryptor.py, and the first argument is whatever user folder, and we have that in our encryption script. So let's just grab that real quick. It was called fake documents folder. Let me grab that. We have that here. I'll minimize that. That's our first one. And now we need the key. So let's do that as well too. Let me snap that back in here and then put that here, email there, and then folders back. So now let's grab the path for this one. So copy as path, and then we'll pass that as the second argument for our decryption. So right now, bear with me, like I mentioned, we are still testing this out just to make sure decryption worked. We did test out encryption, all great. Let's check this one out too. So what should happen is once I run this, our files should be back to normal, and I'll kind of snap it back in there again. Go back to those files. Where are they? Go back to those files just to confirm. I'm opening it up again. Still gibberish. Opening up the Word document, still gibberish. We can't see the email, and I'm not gonna navigate away from this so it doesn't feel like some trickery. I'm just gonna run the decryption. Run it. There was an error. What does it complain about? PyCryptodome. So we didn't install that. So actually, let me close that out. I'll open back the terminal. It's because we didn't do. What I'm going to do is copy this so we don't have to do it again. So I'm going to copy that, and then I'll do Control C to cancel it out. I'll clear it out, and then I need to install that PyCrypto library. So PyCryptodome library. So pip install PyCryptodome. That's what it was. If you come up here, you should see we had an error there. Let me make this bigger. No, not that one. Snap that in there. It was this one. There should be an error here, and that should go away shortly. That red should go away once this is done. There you go. Boom. So that's what it was. We were missing that library. So back there, snap it up, and let's just see if our files are still encrypted. They still are. Open that. They still are. Now I'm gonna run that again. So up just to get that command back. Okay, let me make this bigger, and then I copied it, so I'm gonna paste it. And you see that running? You see that window pop up? Let's open it. I didn't navigate anywhere. Open it up. Boom, our file is back. Let's open up the image. Should be good. Image is back. Perfect. So we know encryption is working. We know decryption is working. When we come back, we are going to package this into an executable. Okay, so we know everything is working. Encryption is working, decryption is working. We tested it out. We got our email sent to us with system log information. We tested out our files, they worked, and we decrypted them and they're back to normal. So what I'm going to do now is package this into an executable, and we're going to be using PyInstaller. So I'm going to start with the encryption one first. Just make this a little bigger, and just to double check, let me close this out and I'll open back terminal, and I will do this pip install PyInstaller just to make sure if it is not installed, or if it's not, or if it is, it will just install the most up-to-date one. So we'll just do that. Pip PyInstaller, and it's installing, it's doing its thing. What I'll do is also do the same thing in the decrypting, just so we don't wait for that. So I'll do that while we are here. Decryption, make that bigger, go to the terminal, do pip install PyInstaller. And the reason I'm doing it this way is, or doing it twice, is because we're running in virtual environments, virtual NVs, so it's just applicable to this project. So maybe install, yes, I did one install, I misspelled that, install, there we go. So that should be running in the background as well. I'll minimize this and we'll go back to our encryption script. That looks like it's done. Sorry, that's just telling me to upgrade pip, but not right now. So I'll do declare, and I have the command to do this. So just a couple of things to call out. This is in a virtual NV, so when we package this, PyInstaller is very kind of weird, like, and tricky in terms of the commands that you put into this, because we have config files and other files and so forth run in. When we do run PyInstaller, we need to account for them by giving it like a path argument and other files and so forth. I have the command written out, I'll paste it here, but I'll explain it when I do this. Before I do that, there were a couple of things or elements in our script that I had commented out because we simply wanted to just kind of test this out. So I'm gonna go back and uncomment some of those things out. I believe it was the places where I was deleting the files that we had created, like the key file and so forth. I want to delete them this time because I don't want them to stay on the system. So I'll remove that. I will remove that comment, and I'll remove that as well too. And just for cleanup purposes, I'm gonna delete them here. I'll delete that. Go ahead and delete that here. Yes, delete anyway. Delete this key as well, and then encryption log, I don't need that because we're gonna get these over email, so we don't want them on the system anyway. This was just more like for debugging purposes for us. So delete. So config, we need it to be packaged in within our executable, so we'll leave that in there. So now what I'll do is, let me grab the command for PyInstaller, and I will explain that as I grab that. So there we go, copy that. And what I'll do is here. So PyInstaller, this is basically the command. One file, we're essentially saying we want all of this script to be converted into one file, which is the one exe file. What we're doing here is we're passing it a path argument, which is basically calling all the libraries that we have in this library folder. We want to make sure we include them. So these include like the PyCrypto, Dome, and all the other things that we installed. All the libraries that we're using, you know, this crypto is here, PyInstaller hooks, all of those things. We want it to be packaged, or it's not going to work. So we need to do that. And then we're adding some data. So data is basically if you had some folders that you wanted to add, this is where you will add it. So we're adding config.ini. That's the only data we have in here. And the way this argument works is you pass it the data, the actual file or folder, whatever, and this indicates which folder, as in source and destination. So the dot here just basically says we're referring to this current folder, this same folder that we're in. If it was something else, you would have put it into something. You would have stated that here, but that's what it is. So that basically this, and then pycrypto.py is the script that we're converting into an exe. What will happen is I'll snap this back in there as well. What should happen is, let me open it here, is, and I'm just going to delete this key file as well because we'll run the exe once we're done. What should happen is once we go into our documents, user, go to Griot, I'm going to go to Python project. This is the PyCryptor. Once we package this executable, there should be a few more directories like build and distribution and so forth, and we should find our exe file, which would be this exact name in that distribution folder. And you notice that we're using this exact name because this is how we were going to reference it when we do that cleanup in our system. Where is that cleanup method where we're doing a system cleanup? We reference pycryptor.exe. It's somewhere in there. I think it's our cleanup. No, securely delete. No, not there. Yeah, there you go. Create self-destruct. This is where we reference this exact name. So if I don't name it that same exact pycryptor, this script might not work when it comes to that. So great. Now let's go ahead and run this command. I'll do this again. I want to run it so we can see the folders show up here, and then I'll hit enter and it should be doing its thing. There you go. And you notice the folders start showing up, distribution and build and all of that. Once it's completed, I'll maximize this as it's running because we can see it here now. Once it's maximized and it's done, it looks like it's done, completed successfully. Snap that back in there and we open our distribution folder, and there you go. We have our pycryptor.exe. And what I'm going to do is I'm going to copy this and we'll place it somewhere. What we'll be doing with this is we'll go into our other machine, which is our Kali machine, sort of our attacker machine, and we'll create, as I mentioned, create a simple HTML site that hosts this file, and we'll send our phishing email to our user to trick them to basically download it and run it on their computer. And we'll use a different machine. If you notice, these are the boxes I'm using. This one says Windows 11 x64. I'll be using this clone machine here to test the victim machine. So we have our executable for that. So I'm going to copy that, place it somewhere for now, because we will put it back into our Kali machine, which is basically where we host that file. So boom, we got that. So now let's go back to, I'm going to go back to the Decryptor project. We'll do the same thing. I'll leave this open. I will maximize that Decryptor. I'll clear this up, and for this one it should be fairly simple because we don't have files and so forth, or configuration files, but I'll do a cleanup here as well. I'll delete the log file because we don't need that. That was just for debugging purposes. I'll delete the summary as well too, because we do get those, and then delete that anyway, and we're good. And for this one, we actually do need to package the library as well too. So it would be very similar command minus the config file. So what I'll do is, since I had that copied, I'll paste that here. I will paste that here. So you notice same command, except a few things. I'm gonna call this Decryptor instead of pycryptor. So I'm gonna call this Decryptor, and then I'm gonna remove the config file because we don't need that argument. I'm going to remove that, and I do want to package the library. So there you go. So one file, same thing, we'll create on one executable file. We do need all the files in our library, such as the pycryptodome, which if I click library again, you should see crypto there, and so forth. So good. Then I'm going to hit enter. I'll make this smaller as well too. Hit enter, and we should see those folders pop up as well too. Hit enter over there. It's working. You saw those folders pop up. We should have both files soon. Perfect. That is completed successfully, and we are good. So I'm gonna grab that as well too. It should be in the distribution folder. We have Decryptor. I'm gonna copy that as well. We can even leave that here because that's just something we're gonna supposedly send the victim. So I'll copy it though and just paste it somewhere. We'll use it later on. Good. So next steps, we are going to create, we're going to go into our Kali machine, and what we're going to do in there, since we know these are working, we'll leave this here. In fact, let me do cleanup in my inbox as well. So I'll clean up the keys here. So my inbox is empty again, as you can see, empty. These files are good. We're not going to use them. Those were just for testing. So we're good in this. We've pretty much built our simulator or ransomware simulator, and we're going to move over to our Kali machine. What we're going to do is set up our web server, set up a simple HTML page with a large button that says download your favorite software, blah blah blah. And in fact, we're going to add just a tiny bit of JavaScript to auto download, or click the download button to download the file onto the computer of the victim, supposedly. And then we're going to craft a phishing email and send it to the user, and basically send a link in there and say, hey, download this and update your software. When I come back, we'll move over to our Kali machine and we will set that up. Okay, we got our Kali machine fired up. So just to recap, this is our attacker machine. This is where we'll have our web server hosted, a simple web server with the exe file that we created, which is essentially our ransomware. And then we'll have an HTML file that basically takes the user to a download link that says, hey, download your favorite software, blah blah blah. And that's how we trigger the malware getting onto a victim's computer. So let's set these up. So I'm gonna fire up a terminal, open it up, open a few more of these, and then I'm gonna just cd documents. I'm gonna go into documents folder, and I'm just gonna make a directory called PyCryptoLab and clear that up. And now I'm gonna copy those executables that we actually had earlier, so it'll be easier because I'm dragging it from somewhere. So I'm just gonna do that, copy that. Actually, I just need the crypto one, so let me copy that, paste that. So we got our executable. This is basically our ransomware, our exe file that we're gonna host. And then another thing I'll do is I'm gonna grab the HTML file that we want to use. So let me do a copy. For some reason it doesn't want me to paste. Good. So we got our index file and our executable. I'll go back to the terminal just to check this out. I'll open up our index file. Is it looking empty? What's going on? Did I get the wrong one? Cancel. No. ls. Okay, well, I'm not in PyCryptoLab, so PyCryptoLab. There you go. And then check out the index file. And there you go. So just to tell you what this does, simple HTML site. We have a big blue button, a banner that says your favorite software download page. We'll have a big blue button that says welcome to your favorite software download page, and a big download button, and which basically downloads that exe file we have in that folder. This is a simple JavaScript where we basically are forcing the user to download, assuming they went there and didn't download. We're essentially calling this to force a click on that button, which automatically downloads. So I'll just X out of this since we didn't make any changes to it. And just to make sure that it's still in there, we still have our exe. Boom. So that's awesome. So what I'll do is, what did I just do there? Cancel. Let's do that. So what I'll do is I will navigate here into that document, and PyCrypto. There you go. Perfect. So ls, just to be sure, clear. Okay. And what I'll do is set up the Python web server. Just leave it on port 8080, and I'll hit enter. So as you can see, we're serving up our web server right now. Just to test this out, I'm gonna navigate to Firefox, go into that URL 8080, and boom, there you go. Look, it downloaded it on purpose. We didn't even click the button and it downloaded it. So I'm gonna go here, and then I'm gonna clear all these up just to make sure that we have an empty. Move to trash, move that to trash. Good. So I'm gonna navigate back to this so you can see that the download function worked. Notice here, it downloaded right away. I didn't even have to click the button. Now if I click the button, it will do the same thing. So go back here, and I'm just gonna delete all of these. All right, perfect, good. So our web server is working. So now we need to craft our fancy email to the user. So we are back in our other favorite attacker machine, which is where we created all our scripts to begin with. So as you can see, I have the email crafted out. This is what it says. As a valued customer, we're excited to offer you exclusive discounts, blah, blah, blah. Claim your 100% discount, your favorite software, and then there's a link. So that link should actually take us to the web server here. In fact, let me confirm the web server address here. Oops. It is 132. So I need to actually change that. 132. Let me grab that. This is the correct one. So grab that here. Go back to that and change that. That's the correct one. There you go. Perfect. So what should happen is once I send this email, our victim here who loves his 100%, his or her 100% discounts, will see that email pop up. He'll enjoy it. They'll click it and enjoy it. Should automatically download because they assume this is a simulation. So we're making some assumptions, but it does work like that most of the time in typically, because you download a file or software and you think it's legitimate and you run it on your computer, and that's what happens. So in our Kali machine, our web server is still running. Let me clear that. Our web server is still running. We should see traffic popping up once they click on that link. Over here, that's the victim's machine, and over here, that's our other attacker machine. We got the email prepped, and what I'm going to do is shoot it up, and we should see that email pop up. So send. I just hit send here, and email is gone. Let's go to our victim machine. We're having a nice day. We're enjoying our day. We'll just keep refreshing to see if anything pops up. We'll give it a couple of minutes. Sometimes it'll take its time. Oh, and wow, there it is. It's here. So let's enjoy this 100% discount. We click in that email. Let me make it a little bigger. Your favorite software, download. What you should see happen is that page that we had served up in our Kali machine that looked like the download page that said this. It should look exactly like this because they're navigating to this. So let me close that here. Then I'll go back to it. So our victim is in their email. They want to enjoy their 100% discount. They click on it, and let's see what happens. Look at that. It actually downloaded, and it says you trusted blah blah blah. Typically people would click on it, even though Windows does a good job nowadays, tells you this is the virus and so forth. So we're just going to say keep it because it's a simulation purposes. We'll say keep it. So we'll show this and we'll say keep it anyway. So as you can tell, but majority of the time what should have happened or what will happen is these executables are signed with digital certificates that make them legitimate from either other attempts of hacking that they've already stolen other digital certificates. So they'll sign this executable to make it look legitimate, and Windows will trust it from a trusted publisher, all of that. But we're just testing this out, so for those purposes. So I'll go into our folder, and we have that file in there. Now, just to simulate, just to show this, so I'm going to close this download page. I'm going to minimize this. We've already downloaded this. And just to test this out, before I actually click this supposedly free update to the software, I want us to just make sure we have some test files in here, right? Just to make sure this is working. So let me open a new one, new Explorer page, move that here. I'm just going to snap this here, snap that here. And what I'm going to do is go to, okay, the email is here. Perfect. That's fine. I can just minimize this. I just want these two. So I'm going to go to documents, and then I'm going to go to fake entire folder test. So I have some, let me make it big so you can see what I'm doing here. So this is same thing, test data from like our previous test cases. just random data I put in there. Oh, sorry, closed that accidentally. Let me open that up. Go to documents. They have all these folders in. And then also, I'm just gonna open up. Let's go to their drive. Let's see. Program files, users, public. Let's see, public documents. Nothing in there. Let me just grab a copy of those folders and then grab them in somewhere, because the idea here is that, assuming that our admin thing works, which I remember we disabled, if this is an admin user and they're running this program as an admin, it's basically gonna go into this, go to local drive and encrypt everything under users. That's how we designed this, so let's be mindful. But if it doesn't run this as an admin, then we'll probably just encrypt everything that's under whatever user, which is this guy Griot. So it will be Griot. It will encrypt everything under his folder. So let's just copy. Let's go documents, grab these same folders. We're just gonna copy them and put them in the public folder, just assuming that he or she somehow runs this as an admin. So go to public documents and I'll just put them here and we'll check it. So perfect. That's copying. Should be done in a second. And we're waiting for that. So all this time, just to recap, we did get our email. We enjoyed our 100% discount. We clicked it, we downloaded. That's all good. We just created some more additional fake testing documents, put it in a public profile, because we only have 2 users, but this is the user that downloaded. So now time to install our favorite software, and then we'll come back and check. Let's do a check first before we do that. So let's go to documents again, just to make sure that nothing is encrypted in here. So we open this random file, all good. Go back, random file, random file, all good. So good. So we are good. So everything is good. If this works, once we click on it, everything under Griot will pretty much be encrypted. So let's run our favorite fun software, favorite updated software, and let's see what's happening. And what will happen is that's running. I'm gonna go to our other machine to see if we get our email. Look at that right away, 1029. Look at that. And let's see if it actually put the file on the desktop. So let's see. Now actually, let's do this first. So encryption log, I think we may have left this part out of the code. We didn't comment it out, but it did leave the encryption log here. So but yeah, there you go. It works just fine though. And I guess we made a mistake. Look at that, they have the key in here. So we were supposed to delete this, but simulation purposes. But anyway, just to give you an idea how it works. So let's go and see if it actually encrypted everything. So let's go to Griot. Let's pick a random folder document. Where was that? Let's go to documents. Pick any random folder. Let's see if it's gibberish or not. Gibberish. So it did work. So it did download. Unfortunately, we left the log file, which included the key. That's not what we're planning to do, but you know, you get the idea. But we go to our attacker machine. We did get the email sent to us. We did get the log file. We did get the key. And if I open this, I'm just gonna open PyCharm back up and show you where we left out, which is why the encryption key did not delete. But ideally we would have deleted it and they would have had no access to it. But we did get all the files. We got the system information, which tells us every file it encrypted. We got the log. Unfortunately, the log leaked our key, but it's okay. So testing purposes, that was the whole point of this. So great. Let me just do this. I want us to look at this. So we go back to Kali just to see we did serve up that message. Notice that it did come, we did get some traffic there. So yeah, it's good. Like I said, unfortunately we leaked our key and left the log file. So close that out, but everything is encrypted. So we can see that. Now that said, see the image is not opening. That said, let's assume we did get our key. So I'm just gonna download the key. Let's go here. I'm gonna download the key. We got the key here. I'm gonna copy that. This is from our other attacking machine in the Windows box. So I'm gonna go to downloads, grab the key, copy that key, put it here so I can grab it back. Go to the victim machine, and now I am saying that I have the key. So copy the key back, put that in. I will just drop it in downloads. There's nothing in downloads, but I'll just drop it in there. Okay, that in there. There, good, we got it. And I'll open command line, assuming okay, you've responded. So let's just finish the simulation. So they respond, they'll say something like, they respond, say, oh, my computer is locked. All files encrypted. I sent the payment, whatever. So we sent them the key. Like this is simulating. So they sent us and we sent them the key. That was just to simulate the fact that they paid. We gave them the key. Now we will give them the decryptor as well. So I'm just gonna assume that we sent them that as well. This is the decryptor file. We'll put it in here somewhere. We'll paste that as well here. And then I'm gonna go to command line and just run this, and we'll go to, we'll do C downloads because it's in downloads, CLS, and we know is Python 3 since we're gonna run it. Decrypt, oh actually it's an exe, so we don't even need to. So decryptor.exe, and remember that we had the path. So let me go back to the old attacking machine just to grab some of that. So remember over here we had, actually let me grab it, I have it here. So we're sending in those two arguments. So copy that, go back to our victim machine. I will paste that here, but I do need to change this because this is let me just make sure this path is correct. Copy as path. Let me just delete this so I can paste that and know that it's correct. So oops, let me grab this open again. Decryptor, paste that, grab that key file, copy that. Okay, so that is good. I just need to change this because what we encrypted was that user's entire drive. So yeah, that will be the correct one. And we close everything out and we run the command just to make sure everything's good. Looks all good. We hit enter and it's done. Now let's open up our folders and see what happened. Close this out. Pick random folder because we decrypted everything. So documents, pick one of the random ones, file 1. We are back to normal. Awesome. I hope you all enjoyed this as much as I did. Remember to hit subscribe, like, share, and I would love to hear what you think in the comment section. And also remember, ransomware continues to be a big threat in the cyberspace. So regularly update your systems, avoid clicking on suspicious links, and contact law enforcement if you are a victim of ransomware. Stay tuned and I'll catch you guys next time.